Okay, thank you everyone. My name is Sonia Giglio. I'm from the Australian Water Quality Centre, and today I'm here to speak to you about macroinvertebrate community development in riffle habitats with onset of flow. So the focus of this presentation is really a small aspect of a much larger environmental flows trials project run by the Adelaide Mount Lofty Ranges NRM board. And the AWQC involvement in this was the monitoring, analysis and reporting of macroinvertebrate community responses and also physical habitat responses to these flow provisions. So this presentation is really around some of our hypotheses that we came up with regarding the driving processes around community development. And these have helped to explain some of the patterns that we've seen in the monitoring data that we've collected. So it's been a 3-year monitoring period that we've been involved in for this project. And our monitoring has really been based around the hypotheses of what responses we thought we were likely to see as a result of these flows. So the study reaches, as Steve went through earlier, Onkapringa, South Para, and 2 reaches in the Torrens River. So our monitoring was very focused on riffle habitat. This is a habitat between pools, so it's generally a lot shallower, it's topographically higher, the stream bed is generally coarser, and the flows through these habitats are generally more turbulent and faster flow than those experienced in the pools. So these habitats we thought would be most constrained by flow reduction. These habitats also support riffle-dependent taxa, so the taxa that really require those flowy conditions to survive or prefer those conditions. So those taxa were our response indicators in this project. Oops. So just to give a quick introduction to some of these macroinvertebrates. So on the left there we've got a net spinning caddisfly or a Cumatopsyche. And on the right, a non-biting midge larva, or Rio tannitarsus. Both of these animals build little shelters for themselves, and they also make little nets out of saliva or silk that they can put out into the flow and catch small amounts of food, or small particles of food that are travelling past in the flow. They can attach very well to hard substrate. And we did notice as well with the Cumatopsyche during this project that they appear to have these over-summering strategies whereby they tend to build little stone cases around themselves in lower flows, and they'll reside under rocks or in deep cracks where there's a bit more moisture to wait out the poorer conditions, I guess. We've also got Simulidae or black fly larvae there. They've got large fans on their heads which they can put out into the flow again and catch particles of food moving by. And they've got good streamlined bodies to help them or prevent them from getting washed away. This is a water penny or a Sphenidae. It's a rare, highly sensitive species. We did hope that we would catch it in this monitoring program, but we didn't. We have found it in the Kangaroo Creek catchment before, and the Kangaroo Creek does enter the Onkapringa very close to one of our sites, so we thought we might come across it, but we didn't. And again, this one's very adaptive for flow. It's very flat and it's got a very strong grip on hard surfaces. So we expected the diversity of these riffle-dependent taxa that it would increase with the onset and maintenance of flows. And initially we hypothesised that it might occur in a staged sort of fashion, whereby it starts with a non-functioning riffle habitat, and with the addition of an appropriate quantity of water, good water quality, speed, coarse substrate, that would then bring in these aerial or emergent or drifted invertebrates into the habitat. And over time, the biomass of diatoms and filamentous algae and cyanobacteria would increase, further attracting algal grazing species, and then eventually attracting more predators into the community, being attracted by these prey species, and forming a good, richer community with a good predator-prey balance. And with sustained flow, it would sort of continue on to a fully functioning riffle habitat. We found after year one that this wasn't the case. We were finding predatory taxa very early in the piece, and they were coinciding or preceding the appearance of the algal grazers, and it was happening a lot earlier than we thought. So this led us to further consider the idea that non-functioning riffle habitat isn't always just a high, dry, sterile bench with no sort of biological activity there, and that led to a revised riffle development pathways hypothesis. So instead of a sequence of events, it was more showing that the end of season proportion of riffle-dependent taxa and stillwater taxa are influenced by the riffle's start point being either wet or dry. So in the wet state, we hypothesised that this is a site that is influenced by groundwater-derived base flow. So Nolan's property on the South Para was one of these sites, whereby often, even in dry times, there was the presence of patches of surface water or even just tiny trickles running through the habitat. So in that sort of site, we are seeing residual pockets of biofilms. The physical microhabitat is developed to an extent, and there may be resting forms of riffle-dependent taxa present in that habitat, such as the Cumatopsyche. The dry state riffle habitat is only receiving base flow from surface water, so it's a lot drier. One such site was below the Barossa diversion weir in the South Para River. In this sort of site, the still water is generally absent. We're not seeing any biofilms there. And there's there's not any taxa really residing in that habitat. Not obviously anyway. There may be egg banks and things, but not as much as the wet site. So from the wet state, it's supporting more stillwater taxa that when the riffle habitat is created, these stillwater taxa can hold on, and that increases competition for incoming riffle-dependent taxa, or those that are in the site, resulting in a more even proportion of riffle-dependent taxa and stillwater taxa. The dry state doesn't have that community present before the creation of the riffle habitat. So aerial migration occurs, environmental drift, and those animals that are very attracted to riffle habitats will move into the site, resulting in a higher proportion of riffle-dependent taxa to stillwater taxa. So in terms of results, did the diversity of riffle-dependent taxa increase with the onset and maintenance of flows? Well, in the Onkaparinga and the South Para reaches, we did see slight increasing trends in richness. Not so in the Torrens reaches. It was generally quite consistent over the monitoring period. So in the Onkaparinga, we did see this increasing trend. However, it was after year one, and that's because we think that the higher flows that were experienced in the Onkaparinga in year one tended to transform the riffle habitats into more like run habitats, and this may have had a displacement effect on some of the taxa residing there. In the South Para River, we did see a slight increasing trend across the trial period, We did have more gaps in the data though for this reach owing to dry conditions and also the water security measures that took place in that year. In the Gorgewia Reach in the Torrens, it was a fairly consistent richness, and we think the magnitude of the base flow environmental water provisions in relation to the discharge derived from the catchment inputs, so the total catchment inputs from rain and other sources, the EWPs were relatively minute, which made it more difficult to to discern what the flows, the community response was to the actual EWPs. In the Gumaraka Reach and Torrens River, again it was quite consistent, and we think that the more permanent nature of the riffle habitats in that reach meant that the environmental water provisions augmented those riffles more so than created them on many occasions, and this may have led to less overall variation in riffle-dependent taxa richness. So was the riffle development pathways hypothesis supported? Okay. We did tend to see two successional pathways determined by a start point, but the relative final proportions that were hypothesised were found to be different. Firstly, the still water component generally comprised the higher proportion at all sites, regardless of what the start point was. And this is likely due to the fact that there are lots more taxa that are generalist type taxa that can live in still water and can live in riffle and can live in both, so more likely to come across those taxa in comparison to the riffle specialists. Secondly, high proportions of riffle-dependent taxa were generally detected at sites with a wet state start point and not the dry, which we originally hypothesised. This graph here is just showing higher numbers or higher richness at the Felixstowe Reserve site in comparison to Silks Road and Athelston Reserve sites further upstream. And this highlights that potentially those low flows and that wet state start point that we see at Felixstowe Reserve is likely to be very beneficial for the riffle-dependent taxa and the richness of those taxa. So it is encouraging to see that riffle-dependent taxa did increase within two reaches, and this isn't unexpected given the suite of species are resilient that we do find in our rivers today. They've got lots of strategies and they have evolved and adapted to varying hydrological regimes. But we didn't find many of those rarer, highly sensitive taxa. So in future it would be good to see an increase in these. So just finally, this project has increased our understanding of the appearance of various functional groups early in the development of the riffle habitat. And the riffle development pathways concept has increased our understanding of how these hydrological start points can influence the richness of the communities or the resulting communities. And it's also highlighted the importance of the dry weather flows through riffles by groundwater. So even those tiny trickles or just very small patches of surface water do seem to be very important for these communities. And that was evidenced by this oversummering strategy that I spoke about with the Kumatasaki. So thank you very much. There's many people involved in this project, but I'd like to thank those listed here. Thank you.
questions for Sonia? If you don't have questions, then we thank all the other speakers as well for taking the time to prepare.